And now let's look at this proof here. NQ bisects angle MNP, and also we are given that angle NMQ is equal to NPQ. So obviously we're going to do it in a two-column proof here, statement and reason column. Number one, obviously we're going to start with the given. So this right here is going to go into the statement, NQ bisects angle MNP, and angle NMQ is equal to angle NPQ. And that obviously is given to us. Number two. Now, it's very important in proofs that you mark things in the picture if they are not marked. Okay. Now, obviously NQ bisects angle MNP. So NQ is right here, and that bisects it. So that means that these two angles up here are going to be equal to each other. So we can say then in our next step that angle MNQ is equal to angle PNQ, and that's the definition of angle bisector. Okay, so we have those two angles equal. We were given that angle NMQ is equal to NPQ, and if you notice those are marked down here already. Okay, and right now we have two congruent angles, or two pairs of congruent angles, and we also will use this a lot in proofs. This side right here is shared by both triangles. Again, side NQ. So we're going to say that NQ is equal to itself. And when you say something is equal to itself, that's the reflexive property. So that's equal to itself. Now, can we say the triangles are congruent? And if you look here, we've got angle, angle, side if I'm going this direction. Angle, side. So we can say they're congruent, so triangle MNQ is congruent to triangle PNQ. Sorry for my messy handwriting here, doing it in explain everything on the iPad with my fingers. So, and that is by angle, side. Okay. Now, number 6, we're going to go through this in this lesson. But if you notice in the next lesson, section 3, side angle side is going to be one of our ones we talk about, and also HL. And that's actually used in this proof, so it does go a little bit more with section 3, but I will go through this with you. So let's do our two columns. Obviously, step number 1 are those things right there, and that's the given. Step number 2. Okay, so if we have NO, if you can see they are already marked, is equal to QO, or to PO, and MO is equal to QO. Oops, I'm sorry. And I think this is actually backwards here. This should say NO is equal to QO. This should be right here, QO. And these QO and PO are backwards here as they're marked in the figure. They're correctly marked in the figure there. Okay, now we also use the fact that vertical angles are always equal. So I can say that this angle and this angle are equal. So I'm going to say angle NOM is congruent to angle QOP and that's the vertical angle theorem, or you could say vertical angles are equal. Now if you notice here, we've got the angle between two sides. So this is a side angle side situation that we can state triangle congruence. So I would say triangle MNO is congruent to triangle PQO, and that is again side angle side. Now notice, sometimes you're just proving triangles congruent. Here they want us to prove those two angles, MNO and PQO, are congruent. To do that, once you have to prove the triangle is congruent first, and then you can state that any corresponding sides or any corresponding angles are congruent once you have the triangles congruent. So we can then state that angle MNO is equal to angle PQO. And remember what we talked about a couple sections ago, or in the last section, that is CP, CTC, corresponding parts of congruent triangles are congruent. So once you have the triangles congruent, then you can say angles are congruent, corresponding angles, or corresponding sides. So you have to prove triangle congruence first.